Hello everyone. Today I want to give you an introduction about the role of graphene oxide in gel polymer electrolytes for solid-state supercapacitors. In fact, energy storage technologies are essential for modern electronics, renewable energy systems, and portable devices. Among many storage technologies, supercapacitors have attracted great attention because they can deliver very high power and charge extremely fast. In this presentation, I will first introduce solid-state supercapacitors, then discuss gel polymer electrolytes, and finally explain the role of graphene oxide nanomaterial in improving their performance. So, what are supercapacitors? Supercapacitors are electrochemical energy storage devices that bridge the gap between traditional capacitors and batteries. Unlike batteries, which store energy through slow chemical reactions or redox reactions, supercapacitors store energy mainly through electrostatic charge, which accumulate at the electrode and electrolyte interface. So, because of this mechanism, supercapacitors can charge very quickly, deliver high power density, and operate for hundreds of thousands of cycles. So these advantages make them ideal for applications such as portable electronics, renewable energy systems, and hybrid electric vessels. What are the different types of supercapacitors? Supercapacitors are generally divided into three main categories. The first type is electric double layer capacitors or EDLC. In these devices, energy is stored through the formation of an electric double layer at the electrode surface. The second type is pseudocapacitors, which store energy through fast and reversible redox reactions occurring on the electrode surface. The third type is hybrid supercapacitors, which combine characteristics of both EDLCs and pseudocapacitors. So each type has its own advantages depending on the application. So why solid-state supercapacitors? Traditional supercapacitor use liquid electrolytes. Liquid electrolytes provide very high ionic conductivity, but they also introduce several problems. These problems include leakage risk, limited mechanical flexibility, safety concerns, and complex device packaging. So, to overcome these limitations, researchers have developed solid-state supercapacitors where the liquid electrolyte is replaced with a solid or gel electrolyte. Solid-state systems are safer and more suitable for flexible and wearable electronic devices. What are gel polymer electrolyte? Gel polymer electrolytes, also called GPEs, are materials that combine properties of both liquid electrolytes and solid polymers. A gel polymer electrolyte typically contains three components: a polymer host, an electrolyte, salt or acid, a solvent or plasticizer. The polymer forms a three-dimensional network that traps the liquid electrolyte inside the structure. As a result, the material behaves like a soft solid, while still allowing ions to move through the liquid phase. So, what are the advantages of gel polymer electrolytes? Gel polymer electrolytes offer several advantages compared to purely solid or liquid systems. First, they provide higher ionic conductivity than dry polymer electrolytes. Second, they maintain good mechanical stability and prevent leakage. Third, they are flexible and lightweight and making them suitable for flexible electronics. So for these reasons, gel polymer electrolytes are widely used in solid-state supercapacitors and flexible energy storage devices. Among different types of gel polymer electrolytes, PVA based are the highly and widely used materials. One of the most commonly used polymers for gel polymer electrolyte is polyvinyl alcohol or PVA. PVA is attractive because it forms strong and flexible films, contains many hydroxyl functional groups, and easily interacts with water and ionic species. In many solid-state supercapacitors, PVA is combined with phosphoric acid or other electrolytes to form conductive gels. In these systems, ions move through hydrated regions inside the polymer networks. So, however, ion transport in gel polymer electrolytes can still be limited by the structure of the polymer matrix. But what are the role of nanomaterials? To improve the ionic conductivity and mechanical properties, researchers often introduce nanomaterials into gel polymer electrolytes. Nanomaterials can modify the microstructure of the polymer matrix and create better pathways for ion transport. Different nanomaterials have been explained and explored in different gel polymer electrolytes, including carbon nanotubes, graphene, metal oxide nanoparticles, and mexen. Among these materials, graphene oxides has received significant attention. But what is graphene oxide? Graphene oxides, commonly called GO, is a 2D-dimensional carbon nanomaterial which is derived from graphene. Unlike pure graphene, graphene oxide contain many oxygen-containing functional groups, including hydroxyl groups, epoxy groups, carboxyl groups. So these functional groups make graphene oxides highly hydrophilic, meaning it can easily disperse in water and interact with polymers. Because of these properties, graphene oxide is very suitable for use in gel polymer electrolytes. So, how graphene oxide improves gel polymer electrolyte performance? When graphene oxide is incorporated into gel polymer electrolytes, it can enhance performance in several ways. First, graphene oxide provides a large surface area which interacts strongly with polymer chains. Second, in oxygen functional groups attract water molecules and help to form hydrated ion that transport through the channels. And finally, graphene oxide can increase the free volume within the polymer matrix and allowing ion to move more easily. So these effects collectively improve ionic conductivity. So as an additional benefits of graphene oxides, we can say that it can also provide several additional advantages, like it can retain water molecules which stabilize hydration inside the gel electrolytes. It can organize ionic pathways, reducing the transport resistance of ion transport routes, and furthermore, graphene oxides reinforces the polymer matrix and improves mechanical stability. So this is especially important for flexible and variable supercapacitors that experience repeated mechanical stress. So, as a conclusions, we can say that solid-state supercapacitors are promising energy storage devices due to their safety, fast charging capability, and long cycle life. So, gel polymer electrolytes play a crucial role in these devices by providing both ionic conductivity and mechanical stability. The addition of graphene oxide nanomaterial can significantly enhance electrolyte performance, and graphene oxides improve ion transport, water retention, polymer structure, and mechanical strength. And finally, because of these advantages, graphene oxide-based gel electrolytes are considered an important direction for the development of next-generation solid-state supercapacitors. Thank you so much for your attention.